At over 2,400 meters above sea level, hidden in the clouds of the Peruvian Andes, lies the mysterious city of Machu Picchu. This is not just ruins. This is a message carved in stone across time. Hey everyone! This is Why, and today we're traveling to one of the most mysterious places on Earth, Machu Picchu. How did the Inca build a city in the clouds without modern tools? Why is Machu Picchu called an engineering marvel? Stay tuned, you're about to find out. Machu Picchu is located in the Peruvian Andes at an altitude of about 2,430 meters, 7,970 feet, above sea level. It sits between two iconic peaks, Machu Picchu, meaning Old Mountain, and Huayna Picchu, Young Mountain. The site lies near the ancient Inca capital of Cusco, surrounded by lush tropical forests and misty cliffs that kept it hidden from the outside world for centuries. Thanks to its remote and elevated position, Spanish conquistadors never discovered Machu Picchu, leaving it remarkably preserved. It is 80 kilometers, 50 miles, northwest of Cusco on the crest of the mountain Machu Picchu. As such, it had a milder climate than the Inca capital. It is one of the most important archaeological sites in South America, one of the most visited tourist attractions in Latin America, and the most visited in Peru. Machu Picchu is situated above a bow of the Urubamba River, which surrounds the site on three sides, where cliffs drop vertically for 450 meters, 1,480 feet, to the river at their base. In the mid-15th century, the Inca Empire, or Tawantinsuyu, was at its peak. Under Emperor Pachacuti, ruled 1438-1471, monumental construction projects began, including the mysterious Machu Picchu. In 1911, American historian and explorer Hiram Bingham traveled the region looking for the lost capital of the Neo-Inca state, later established to be Vilcabamba, established by Manco Inca after the Spanish conquest, and was led to Machu Picchu by a villager, Melchor Arteaga. Bingham found the name of the Peruvian explorer Agustin Lizárraga and the date 1902 written in charcoal on one of the walls of the Temple of the Three Windows. Initially disappointed, he documented in his pocket field journal, Agustin Lizárraga is discoverer of Machu Picchu and lives at San Miguel Bridge just before passing. However, while Bingham initially acknowledged Lizárraga as the discoverer in his early writings and speeches, including Inca Land, 1922, he gradually downplayed Lizárraga's role until, in his final version of the story, Lost City of the Incas, 1952, Bingham claimed to have found the site himself. Though Bingham was not the first to visit the ruins, he was considered the scientific discoverer who brought Machu Picchu to international attention. Bingham organized another expedition in 1912 to undertake major clearing and excavation. The city is divided into two main zones, agricultural terraces and the urban/religious quarter. The terraces stabilized the steep slopes, controlled erosion, and provided fertile ground for crops. Key ceremonial structures, the Temple of the Three Windows and Intihuatana, were aligned with astronomical events. The Incas used them to track the sun and seasonal cycles. Terraces and retaining walls. Step terraces stabilized the slopes and prevented erosion. Each terrace incorporated drainage layers of gravel, sand, and fertile soil. Ashlar masonry, dry stone. Granite blocks were cut and fitted with millimeter precision. No mortar used, joints are so tight that not even a blade can pass between stones. This technique enhanced seismic resistance, blocks shift slightly during quakes but never collapse. Trapezoidal design elements. Doorways and window openings are trapezoidal, adding structural strength. Trapezoidal niches and lintels maintain stability and visual harmony. Advanced water management. A sophisticated network of aqueducts and fountains channels excess rainwater away. Hidden conduits within walls redirect water to agricultural terraces. Temple and residential sectors. Residential buildings feature evenly spaced ventilation windows for airflow. Temples of the Sun, 3 windows. Sit on solid rock platforms to ensure stability and celestial alignment. The Incas didn't use the wheel in construction. Instead, they relied on stone hammers, bronze tools, and wooden wedges to cut and shape stone with remarkable accuracy. Stones were fitted with such precision that no mortar was needed. This dry stone technique, known as ashlar, made the walls resistant to earthquakes. The blocks would shift slightly but never collapse. Massive stones were transported by manpower along carved paths, using wooden rollers and water to reduce friction. Thousands worked in unison, guided by sacred geometry and tradition. Quarrying and stone preparation. The Incas selected granite veins in nearby mountain outcrops. Wooden wedges soaked with water created fractures, allowing large blocks to be split off. Stone hammers and chisels shaped the rough block, then fine sand was used to polish the surface. Ashlar masonry, dry stone construction. Blocks were fitted with 1 to 2 millimeters precision without any mortar. Each granite slab was repeatedly tested and adjusted to ensure perfect joins. The ashlar technique allowed walls to breathe and flex slightly during earthquakes without collapsing. Transport of massive stones. Blocks weighed from several hundred kilos up to over 10 tons. Wooden rollers and sledges ran along prepared earthen or stone tracks. Workers poured water and occasionally plant oil on the track to reduce friction. Hidden channels and drainage systems. Concealed aqueducts were carved inside walls to channel and distribute water. Excess rainwater drained through stone gutters down to the agricultural terraces. Maintenance and inspection were done via vertical shafts leading to the conduits. Labor organization and rituals. Work crews (alas) were organized by kinship and territorial affiliation. Construction phases were accompanied by rituals, offerings, songs, and dances to invoke divine favor. Precise planning and logistics were overseen by the Yamas administration, responsible for provisioning and coordination. By the late 15th century, Machu Picchu was a spiritual and scientific center. But after the arrival of Europeans, the site was abandoned and hidden from the outside world. Rediscovered by Hiram Bingham in 1911, Machu Picchu continues to captivate the world. Engineers and scholars still marvel at its resilience and sophistication. Why is Machu Picchu called an engineering marvel? Machu Picchu is not just an ancient city, it is a masterpiece of engineering built without machines, cement, or metal tools. The Incas used their deep understanding of nature, terrain, and water flow to create something that few civilizations could match, even today. Here's why it's considered an engineering wonder. Earthquake-resistant design. Stones were cut and placed with such precision, no mortar was needed. During earthquakes, the walls flexed with the ground instead of collapsing. Advanced drainage system. More than 130 hidden canals safely divert rainwater. Machu Picchu receives up to 2,000 millimeters of rainfall yearly, yet it doesn't flood. Terraces and structures are built to channel water away from foundations. Harmonious use of the landscape. Instead of flattening the mountain, the Incas built with the contours of the land. Stones were quarried on-site and used immediately in construction. Infrastructure that lasts. Most buildings, terraces, and canals remain intact. Fountains, steps, and temples still function today. Machu Picchu is more than stone ruins. It's a symbol of harmony between human creativity and nature, a legacy of design, faith, and endurance carved into the mountains. Thanks for joining us as we explored the secrets and greatness of Machu Picchu. If you enjoyed the video, give it a thumbs up and don't forget to subscribe to the Why channel for more amazing content. Drop a comment below. Tell us what ancient civilizations, mysteries, or megastructures you'd like us to cover next. See you soon, and may the spirits of the past guide your curiosity.